Welcome to ERC Tipsnology. This is day 4 of our microcontroller tutorial. Let's start. Why program in C? Compilers produce hex files that is downloaded to ROM of microcontroller. The size of hex file is the main concern. Microcontrollers have limited on-chip ROM code space because 8051 is limited to 64 kilobytes. C programming is less time-consuming, but has larger hex file size. The reasons for writing programs in C: it is easier and less time-consuming to write in C than assembly. C is easier to modify and update. You can use code available in function libraries. C code is portable to other microcontroller with little of no modification. A good understanding of C data types for 8051 can help programmers to create smaller hex files. Examples of C data types are unsigned char, signed char, unsigned int, signed int, s-bit or single bit, bit, and sfr. The character data type is the most natural choice. 8051 is an 8-bit microcontroller. Unsigned char is an 8-bit data type in the range of 0 to 255, or from 0 to FFH. Unsigned char is one of the most widely used data types for the 8051. Examples are counter value and ASCII or ASCII characters. C compilers use the signed char as the default if we do not put the keyword unsigned. Write an 8051C program to send values 00 up to FF to port P1. Take note that these are hexadecimal numbers because if there is a letter F and only hexadecimal has the letter F as a number. In the solution, we start in line 1 with hashtag include space less than reg51.h greater than. Then, on the second line, we write void space main open parenthesis void close parenthesis. Then, on the next line, we put an open curly bracket. Then, on the fourth line is unsigned space char space z semicolon. Then, on the fifth line, we put for space open parenthesis z equals 0 semicolon z equals less than or equal to 255 semicolon z plus plus open parenthesis. Then, on the next line, the sixth line, we put P1 equals z semicolon. And finally, on the last line, a close curly bracket. Remember, first, pay careful attention to the size of the data. Second, try to use unsigned character CHAR instead of integer INT. If possible, write an 8051C program to send hexadecimal values. For ASCII, ASCII characters of 0, 1, 2, 3, 4, 5, A, B, C, and D, to port P1. In the solution, in the first line, we put hashtag include space less than reg51 dot h greater than. Then, in line 2, we put void space main open parenthesis void close parenthesis. Next is an open curly bracket. In the fourth line, we put unsigned space char space mynum open square bracket close square bracket equals double quotes 0 1 2 3 4 5 A B C D double quotes semicolon. This is followed by unsigned space char space Z semicolon, and then in line 6 for open parenthesis Z equals 0 semicolon Z less than 10 semicolon Z plus close parenthesis. Then on line 7 we put P1 equals mynum open square bracket Z close curly bracket, and finally the close curly bracket. Write an 8051 C program to toggle all the bits of P1 continuously. In the solution, you will see 2 slash signs followed by toggle P1 forever. This is called comment line. Then, from line 2, 3, and 4, you will see again hashtag include space less than reg51 dot h greater than followed by void space main open parenthesis void close parenthesis followed by open curly bracket. On the fifth line is for open parenthesis bracket semicolon close parenthesis. This line means it will repeat forever whatever is inside its open and close curly bracket. And as you can see, there are 2 instructions inside the open curly bracket and the close curly bracket. These are P1 equals 0 x 55 semicolon followed by P1 equals 0 x AA semicolon, then a close curly bracket. Then in the last line, again, there is a close curly bracket. What does P1 represent? P1 means port P1. Remember that there are 4 ports in 8051. Ports P0, P1, P2, and P3. In this problem, only P1 is needed. 0x means hexadecimal number. 55 is a hexadecimal number, which is equal to 0101 in binary. AA is a hexadecimal number, which is equal to 1010 in binary. So, here, P1 will have the values of 0, 1, 0, 1, and then it will become 1, 0, 1, 0. When 0 becomes 1, or 1 becomes 0. This is called toggle. Signed character, or signed char, is an 8-bit data type. It uses the most significant bit, MSB, data 7, or D7, to represent negative or positive. Signed char give us values from negative 128 to positive 127. We should stick with the unsigned char unless the data needs to be represented as signed numbers. For example, temperature, which can be negative or positive. Write an 8051C program to send values of -4 up to +4 to port P1. In the solution, / is used for the comment, just to tell what the program is all about, which is about signed numbers. But this is not necessary. The program may still run or execute without it. Then, we again see the hashtag include space less than reg51.h greater than followed by void space main open parenthesis void close parenthesis followed by open curly bracket. Take note that all open curly bracket must have its close curly bracket, so don't forget the close curly bracket in the end. In the fourth line, my_num is an array variable. Its data type is character, and it contains all of the integer numbers between -4 and +4. -4, -3, -2, -1, +1, +2, +3, and +4 are the numbers between -4 and +4. There is no 0 because it will become 9 numbers, so we did not include it anymore. Our array can only take 8 numbers. It was just arranged in a different way, but still the same integer numbers. Let us just assume here that we wanted these numbers in this way. In the line 5, the unsigned character variable z was also declared. Below that, we have the for loop statement that repeats 8 times from 0 to 7. Take note that less than 8 means the limit will be 7, and less than or equal to 8 means the limit will be 8. In this example, z will be from 0 to less than 8, which means it will be repeating P1 equals my_num bracket z bracket semicolon 8 times. 0 to 7 is 8 times. Therefore, be careful in using less than and less than or equal to. On the other hand, in the next statement, P1 equals my_num open square bracket z close square bracket semicolon. This will take the values from the array my_num array 1 by 1 to the 8 pins of P1. P1 P1.0 to P1.7. P1.0 will take the value of my num bracket 0 bracket, which is 0. P1.1 will take the value of my num bracket 1 bracket, which is positive 1. P1.2 will take the value of my num bracket 2 bracket, which is negative 1. This will be continued until P1.7 takes the value of my num bracket 7 bracket, which is negative 4. Remember that the parts of the array, called array elements, are using the numbers 0 up to 7 as their index number. Unsigned and signed integers. The unsigned integer, int, is a 16-bit data type. It takes a value in the range of 0 to 65,535. In hexadecimal, it's 0000 up to FFFF. A letter H in the end means it is hexadecimal. The unsigned integer also define 16-bit variables, such as memory addresses. It also sets counter values of more than 256. Since registers and memory accesses are in 8-bit chunks, the misuse of integer variables will result in a larger hex file. Signed integer is a 16-bit data type. It used the most significant bit, MSB, data 15, D15, to represent negative or positive. We have 15 bits for the magnitude of the number from negative 32768 to positive 32767. Single bit. Write an 8051C program to toggle bit D0 of the port P1, P1.0, 50,000 times. In the solution, we write s-bit space my bit equals P1 caret 0 semicolon. In the line 5, the unsigned integer variable z was declared. On the next line, we have the for loop statement. This for loop statement will start from 0 up to 50,000 because of the less than or equal to 50,000 condition. Z++ means add 1 to the variable z. So, it will repeat the two statements inside the for loop. That is, my bit will toggle between 0 and 1. My bit becomes 0, then 1. 50,000 times. Now, let's talk about bit. The bit data type allows access to single bits of bit addressable memory spaces from hexadecimal number 20 to 2FH. To access the byte size SFR registers, we use the SFR data type. Talking about data type, size, in bits, and data range or usage. Unsigned char is 8 bits in size, with a data range of 0 to 255. Signed char is also 8 bits in size, but it has a data range of negative 128 up to positive 127. Unsigned int, or unsigned integer, is 16 bits in size, with a data range of 0 to 65,535. Signed, int, or signed integer, is also 16 bits in size, with a data range of -32,768 up to 32,767. S-bit is only 1 bit in size, and is SFR bit addressable only. Bit is also 1 bit in size, and is RAM bit addressable only. SFR is 8-bit in size, and has RAM addresses of hexadecimal numbers 80 up to FFH only bit addressable only. That's the end of day 4 in our microcontroller tutorial. Please subscribe, share and click the notification bell for the next tutorials. See you again here in ERC Tipsnology. Thank you and goodbye.